All right, welcome everybody. Let's do this. So, lesson 21, this will be a really short lesson. Students recognize when a linear transformation of the form L, x, y, a, b, c, d, x, y represents the rotation and dilation in the plane. So, what I'd like you to do is, let's say if we have this matrix multiplication, and this is our 2 by 2 matrix, right? What is this doing? It is changing some point x, y. So what I'd like you to do is, I'd like you to just simply calculate this and see what's happening. What's the goal for today? How is this 1, 0 being changed by this multiplication? So what I want you to do is pause the video and simply just do the multiplication to figure this out. And if you want to continue on, this should be our answer, right? So let's move on. What is the game plan? What does this do to my point 1, 0, right? It makes this point 1, 0, and now becomes 1, 2. Okay, so what does this mean geometrically? What I'd like you to do is take a second and just write this down in your notes, and this is going to explain what is happening geometrically, okay? And then I'll show you. So take a second, pause, just have this in your notes, and then let's continue, okay? Here, let's take a look. Notice that what is the distance from here to here? Actually, let me get another. What is the distance from here to here? This distance is 1, okay? Let's see, how does the distance change from 1 to this? Well, let's take a look. If I know this is my new triangle, right? If I want to find the distance from here, from the origin to here, if this is 1, what's this distance here? It has to be 2. So if this is 1 and this is 2, how can I find the distance here? Well, we could use our favorite a, b, c. We could use our a squared plus b squared equals c squared. Okay? And now what happens here, this is my a, and that's my b. So this is 1 squared plus 2 squared is equal to c squared. So this is 1 plus 4 equals c squared. This is 5 equals c squared. And if I take the square root, c is equal to square root of 5. Okay? So our distance now is square root of 5. Okay? What will be our degree of rotation? Well, how can we find that out? Here, we need to use our calculator to find the argument from here to here, right? How much rotation is happening? So here, this would be, if I have this point 1 comma 2, right? What can I use? I could use tan inverse of 1 over 2, and that will give me the amount of rotation. I'm sorry, not 1 over 2. 2 over 1, right? Because this is tangent is, what is this? Opposite over adjacent, right? So opposite over adjacent. And let's see how much rotation we'll get. So if I turn my calculator on, we go to, let me fix the camera a little bit. If I go to, let's reset the calculator. So second, memory, go to reset, enter, all RAM, reset, okay. Now if I go to mode, and now here I want to go to degree, I hit enter. Okay, so now our calculator is in degree. Now let's go to second quit, and then how do I put this into the calculator? How do I put tan inverse of 2 over 1? I just go second tan, and then I just do 2 divided by 1, and I hit enter, and I get 63.43. So what does this 63.43 represent? It represents the the amount of rotation that happened from this point to this point. Okay? And let's just take a look at let's take a look at this, right? Let's pause the video for a second and just take a look at this. What I want you to do is try and read this and understand what we just did here. How does it translate to this, all right? Of some arc a plus bi, this is basically just telling you to do the tan inverse, okay? And this dilation, you could use the modulus form of a plus bi, or you could just do this little trick with the Pythagorean theorem to find the modulus here. what I'd like you to do is show how this matrix multiplication changes 2, 2. That point, where is 2, 2? Where is 2, 2? It'll be, bam, right here, right? How does this change this point? Okay? How does this change this point of -3 and 4, which is here? Okay? What I want you to do is work on that, and then we'll work on the solution together.